assign slot. Again, nodes transmit data during their assign slide. Slots. Okay, so for each node, some the time slot is specified. Okay, and each node can send its own data in the time slot that uh, is defined for it. Okay, so because of time sharing and because of the we want to uh, omit the conflict uh, between the nodes and send the message. Okay, so there is a need to define the time slot for each node, and each node in the determine specified time slot can send the data to the other nodes as well, to the cluster head or to the base station. And the energy efficiency of the leech is mainly due to data fusion. The energy efficiency of the leech is mainly due to data fusion. Uh, okay, I talk about the data fusion. The data fusion is the process of integrating multiple data sources to produce more consistent, accurate, and useful information than that provided by any individual data source. Okay, so the energy efficiency of the leech is mainly due to data fusion. Okay, shortly, the leech protocol divides sensor nodes into cluster. Every node sends data to its cluster head, and the cluster head sends data to the sink or base station after data aggregation. Adjacent nodes automatically form cluster. This is done by distributed algorithm. Some nodes become cluster head, and other nodes become other nodes choose a cluster to join. Okay, so again, some nodes, for example, in this example, in this figure, 3 nodes, they become cluster head, and other nodes choose nearest cluster to join. Okay, and you must know randomization election is used to balance energy nodes. Okay, we can go to the next slide. Uh, Design for sensor network where an end user wants to remotely monitor the environment, where the data for the individual nodes must be sent to central base station, often located far from the sensor node. Okay, the leech protocol is desirable properties for protocol on these networks. Okay, desirable properties for protocol on these networks. Usually, they use 100 to 1,000 of nodes. Uh, they want to maximize system lifetime and maximize network coverage, and also they use uniform battery operated nodes. The use of distributed cluster formation and local processing, the use of distributed cluster formation and local processing to reduce global communication, align the randomized rotation of the cluster head, allow leech to achieve the desired properties while being energy efficient. Okay, I talk about this. Okay, by distributed cluster formation. Okay, and after that, local processing, which can be done in cluster head. Okay, the global communication can be reduced with random rotation of cluster. Okay, these are some other uh, properties of the cluster architecture. Okay. After cluster architecture, you can see the layer network architecture. Uh, this architecture consists of a few hundred sensor nodes. The nodes can be half or full duplex, a single powerful base station. Yes, a single powerful base station. Network nodes are organized into concentrated layers. Yes, yes, this is the concentric layers. The base station is placed in the center, and other nodes are grouped into some layers around the base station according to the hop counts between each node to the base station. Layer a set of nodes that have the same hop count. Each layer is a set of nodes that have the same hop count to the base station. Okay, for example, these two nodes has one hop count, one hop uh, to the base station. The distance of these nodes to the base station is 2. Okay, and additional mobile nodes traverse into networks. Additional mobile nodes traverse in the network. Okay, in this figure you can see two mobile nodes. These mobile nodes can be traverse the network to according to the base station interest. Uh, okay, so these are two appropriate nodes which can move in the environment. Okay, these nodes use a mobilizer component to move around in the environment. And okay, additional mobile nodes traversing the network. After that, wireless multi-hop infrastructure network architecture. Okay, one famous uh, network architecture that use the layer network architecture is wireless multi-hub infrastructure network architecture, which is called MINA. Okay, again, in this figure, you can see a 10-node sensor network depicts a cluster of node 3. There are two mobile nodes. In this slide, uh, some features of MINA architecture is introduced. This architecture consists of a set of wireless sensor nodes, create an infrastructure, provide sensing and data forwarding functionality. Sensing and data forwarding functionality, which is no two is the is a data gathering process entity and communication link to larger network. I say you that the base station is the gateway that connect the wireless sensor networks to the wide area network to the internet. Okay, so the base station is a data gathering processing entity and also communication link to the larger network. Shorter range, low power transmission prefer to cover operation and to conserve power. Again, shorter range, low power transmission preferred for covered operation and to conserve power. Okay, after that, I'm going to talk about data dissemination architecture and protocols. Data dissemination. Uh, in at a network, the traffic is peer-to-peer between two each node. Okay, so multi-hop routing is used for communicate data. Multi-hop routing is used for communicate data, but in WSN, other traffic models are possible. Okay, so in addition to multi-hop routing, uh, two other traffic model are possible. First, data collection model. Second, data diffusion model. Uh, okay, what is data collection model? Okay, it's so clear. Source send data to the collection entity. Yes, the collection entity can be gateway. Okay, it can be done periodically or on demand. Okay, sometimes the gateway or seeing send demand to the source nodes, and source send data to the collection entity, and sometimes the source node periodically send data to the gateway or sink. Okay, another traffic model is a data diffusion model. Uh, uh, three uh, concepts are defined in the data diffusion model. First, source. A sensor node. What is a source? Source is a sensor node that generate data. Again, a sensor node that generate data pass on its sensing mechanism observation. Again, it generate data and pass on its sensing mechanism observation. Okay, another concept is event. What is event? Event is something that needs to be reported. Event is something that needs to be reported, e.g., in target detection, some abnormal activity. Okay, so again, in target detection, okay, this is one interest for something in the WSN. Okay, in for this interest, the abnormal activity must be reported to the base station and to the sink. Okay, sink or base station. Okay, the sink is a node randomly located in the field that is interested in events and seeks such information. Okay, so again, sync is interested in events. Okay, so sync must send message to the sources, and it must determine its interest to the sources, and source uh, generate data, and when they detect appropriate data, the data and event. For example, target detection. Okay, the source uh, create a report, a message to report the event to the sink. WSN a routing protocol requirement. Um, WSN routing protocol requirement. Okay, this protocol, the routing protocol of WSN must be simple and robust, self-configured and distributed algorithm must be used for routing protocol, and the routes must converge quickly. This protocol must have minimal overhead. Resource use must be minimal, must be energy efficient. Communication is another feature of WSN routing. Effectively use limited bandwidth for communication in WSN, and ease of deployment. Okay, reasonably good performance even in harsh environment. Okay, in this figure you can see the data diffusion. In this figure you can see some sensors that are spread around the environment. Okay, these sensors are called sources, and two sink are specified in this figure, sink 1 and sink 2. Each sink can send its interest to sensors, to sources. Okay, and if each source, each one sends observe uh, and detect any abnormal activity. For example, if the source see a tiger, okay, it must report this event to anything according to its interest. Okay, by executed by sensor nodes. Okay, why a task is defined? Why a task is defined? Uh, for defining any task, uh, uh, okay, the name data is used. The name data consists of two values, a pair values including attribute and value. Again, name data consists of attribute and value. Sync node requests sync node task is strong a sensor node in the specified region, in this region, to track for animal, this region. Okay, this is this region, which is specified by this circle. Okay, the above task instruct a sensor node in the specified region to track for animals. If animal is tracked or detected, okay, if animal is tracked or detected. Then send observation every 20 milliseconds. The interval is 20 milliseconds for 10 seconds. Again, every 20 milliseconds for 10 seconds. This observation must send to the sink, to the base station. The above task is sent via interest message, and all, okay, this message is called interest message. The interest message uh, is sent, and all sensor nodes register this task in the, okay, it is called the uh, interest, I think, registry, cache, uh, interest cache, I think. Yes, again, this task is sent via interest message for to all nodes, and the source node must register this task in the interest cache. When a node detects an event, it must construct a data event message. Okay, data event message is the message that is created by source node when a source node detects the animal. Okay, so in this environment. Okay, this is the data event example. Okay, type animal, instance tiger, location. Okay, this is the actual location. This is the intensity, confidence, and timestamp. These interests, okay, interest and gradients. I say to you that data event must be sent to the sink. For each active task that a sink is registered in, sync broadcast interest to its neighbors, sync broadcast interest to its neighbors, initially to explore, to could set large interval, sync refresh each interest using timestamp, and each sensor node maintain an interest cache. I talk about the interest cache. Okay, you know, interest cache is a memory that all interests from the sync are stored in the interest cache. Interest aggregation is possible. Okay, when a node receive an interest, when a node receive an interest from the sync, okay, first check cache to see if an entry is present. If no entry, create an entry with a single gradient to neighbor who send this interest. Gradient specify the direction and data rate. Again, gradient specify the direction and data rate. Resend interest to subset of its neighbors. This is essentially floating-based approach and other probabilistic location-based and other intelligent forwarding approach possible. Similar to multicast tree formation at sink instead of at source. Okay, you can see interest propagation. The sink interest propagation to, for example, to these three sensor. This sensor send the interest to these three. Again, this sensor sent to the this area, and some sensor which are placed in this area. Okay, this is called interest propagation. Interest propagate from the sink to the sources. When a sensor node detect a target, it search interest cache. Again, search interest cache for matching entry. If one compute highest request event rate among its gradients, instruct sensor subsystem to generate data at this rate and sends data to neighbors on its gradient list. And intermediate nodes maintain data cache Cache recently received events, forward events data to neighbors on its gradient list for usual rate or reduced rate intelligently. Yes. Thank you all participants in this class. I know the time is over, and I think you are tired, and I can finish this session now. If you have any question, okay, I waiting to hear your question. If you don't have any question, okay, I can finish the class at this time. You're welcome. You're welcome. خدا حافظ شما باشه. خدا نگهدار. Have a good time. Bye for now. خدا حافظ همه.